In the first step of a study I am conducting, I need to attach a formaldehyde group to a compound. Since this is an ongoing project, I won't disclose the structure of the compound to be formulated. Let's call this compound the mysterious compound. One of the most commonly used methods for formulating an electron-rich aromatic compound is the Vilsmeier-Haag reaction. I will also use this reaction to try to formulate my mysterious compound. Since this reaction needs to take place under cold conditions, I prepare an ice bath. The Vilsmeier reagent is formed by the reaction of phosphoryl chloride with dimethylformamide. Phosphoryl chloride is a highly toxic substance. Additionally, it reacts with moisture in the air, forming phosphoric acid and hydrogen chloride gas. For these two reasons, it needs to be stored properly. Now I add the calculated amount of phosphoryl chloride. Let's secure the bottle again. I add dimethylformamide. The reagents will mix at this temperature for an hour. In this reaction, the electron pair on the nitrogen of dimethylformamide moves on to the single bond and oxygen attacks phosphoryl chloride. The released chlorine attacks the iminium carbon, reopening the double bond, and as the bond moves on to the single bond, the carbon-oxygen bond breaks. At the end of this mechanism, the Vilsmeier reagent, I now weigh the calculated amount of the mysterious compound. For an effective reaction, I need to grind the solid into a fine powder. The Vilsmeier reagent is ready. I prepare an oil bath to use for heating. Now I add the mysterious compound. The reaction will be heated for 4 hours. I was expecting a darkening in color but not black. The mysterious compound may have polymerized or undergone other reactions. I hope all these reactions are just tight reactions. In the workup stage of the reaction, I need to hydrolyze the iminium compound into an aldehyde group. For this, I first add water and then potassium carbonate. The carbon dioxide gas produced by the reaction causes foaming. Initially, I should have added potassium carbonate in small portions, but I added a bit too much. The foaming has stopped at just the right level. I continue adding potassium carbonate until no more foaming is observed. I extract the organic materials into ethyl acetate. Now, to get a general idea of the substances present in the reaction mixture, I perform thin layer chromatography. First, I examined the plate under 254 nanometer UV light. The starting material is still present in the mixture, but two new products have formed. These are probably the monoformulated and deformulated products. Here is the plate under 356 nanometer light. As a result of formylation, the fluorescence wavelength of the compound should shift to the red region. Therefore, observing fluorescence in the visible region for the formulated products is expected. I dry the organic phase with magnesium sulfate. Then I evaporate ethyl acetate, leaving behind only the products in the reaction mixture. The formed substances will later be profiled by column chromatography. Maybe that will be the subject of another video.